Let me welcome Professor Keller to our lecture. To our lectures, he will, as I anticipated before, he will talk about the models and the problems related to machine consciousness. Antonio Keller is a full professor in robotics at the University of Palermo and an associate researcher of the National Research Council in Italy. He actually has published many papers in cognitive systems, consciousness, and actually edited a book with Riccardo Manzoschi, Artificial Consciousness. And he has been the founder and the chief editor of the Journal of Machine Consciousness. So he is a very knowledgeable person in both AI and robotics and in the field of machine consciousness, which is the topic of his today's lectures. Antonio, the floor is yours. Ciao.
And for me, today, it is really difficult to find. According to Search, which is not the answer comes room program. Consciousness, according to CERN, consists of qualitative subjective states and processes of transience or one. So, according to CERN, consciousness begins when we wake up in the morning from a dreamless sleep and continues until we fall asleep again, or die, or go into a So, the definition is quite broad. Consciousness is one of the words that is really difficult to define. Nevertheless, everyone of us knows what is consciousness. It's just like life or, I don't know, these very broad words, intelligence. It is very difficult to define this word, but in some way we all know what we are talking about. And motivation. Why we should study, why we should investigate about machine consciousness. In my opinion, there are more or less three main motivations among many others. The first one is that we would like to have to build some kind of artifacts like us. We want robots that are conscious. We would like to have robots able to feel emotion, able to have some kind of affect. We want to build a robot with experience, with imagination, creativity. So we want to build, but we are engineers, we are people from computer science, so we want to build even better robot. But on the other side, student consciousness could be useful also from the point of view of cognitive science, of philosophy and so on, because it is possible to have some kind of experimentation of these theories. So we are able to build some laboratory models in order to study natural systems. And this is an important point in my opinion. And on the other side, the third motivation is that we need some kind of better intelligent control in firms, in industries, and so on. So, also from the point of view of industry, it would be profitable to have a better system aimed with cost. From this point of view, I would like to remind a paper some years ago by our guest Fabio on the new experimental science of physical quantum systems. By using cognitive science, by using AI, robotics, and new science, we could give some new views, some new answers to the very old questions given us by philosophy. So, more means to give new answer to the old philosophy. And some people ask when machine will become. So there will be some kind of date in which we could expect machine to become. If we consider some kind of calculation, we may expect that a conscious machine may require this same complexity of the human brain. The human brain is 10 to 12 neurons, and each neuron has 10 to 50 acids. So in our brain, more or less, we have 10 to 50. You consider that. So, I was just saying, when a machine will be conscious. If we consider some kind of calculation, whether a conscious machine should require the same complexity of the human brain, more or less we need 5 million gigabytes. Taking into account the well-known Moore's law, starting from 1966, the RAM increased by a factor of 10 every 4 years. By doing some kind of very easy calculation, we may expect 2029. So we are near here in some sense. So it's not so far from that. Different calculations give different years, but more or less we are expecting in 10, 12 years to have a computer which could be of the same complexity of the human brain. And in fact, in 2008, I noticed this advice in a London tube. Imagine a phone that's image conscious by Samsung. It was before the iPhone era. But even in 2008, the Samsung asked the problem of having a conscious telephone. But are we sure that we do really want a conscious robot? Some days ago, Dilbert published these strips in which you can see a robot that asks a person, do you really want to be conscious? So being unconscious will give some advice in some sense. Okay. Now let's enter more into the details of machine consciousness. There is a brief history in machine consciousness. As far as I can know, in the first ideas of artificial consciousness has been proposed by NEM in this very old book, in Cybernetic Machines, published in Budapest in 1962. It has been translated. It's a really visionary book, this book of NEM's, because it talks about artificial consciousness. It is about emotion machine. It is about automatic composition, and so on. It's a really visionary book in 1960. And in the new era, let's say, in 1992, Igor Alexander, in a conference, in Neural Network Conference in Brighton, presented a paper capturing consciousness in neural systems. And he says that the hunting system of machine consciousness is open. I remember I attended this conference, and I remember this kind of strange claim by Igor Alexander, and it was for me it was the first time that I heard about. In 2001, there has been a Cold Spring Harbor meeting, and the concluding comments says clearly that we know of non-fundamental principle operating in this universe that forbid the subjective feeling in art, design, or evolved by you. So this quote clearly states that there is no law that forbids the existence of a conscious art. And it is an important, in my opinion, is an important milestones in the study of machine. Today, a broad community of people study machine consciousness. There are journals, there are books, there are special issues of journals, New Scientist, IEEE Spectrum, which is amazing, which is a journal, and a special issue on machine consciousness, and so on. So there is a broad community of people studying machine consciousness. Igor Alexander proposed some kind of axioms for robot consciousness. So what are the minimum for robot machine to be conscious? He proposed these five actions. So the first act more into evidence this action. The first action, so let A be an agent in the world. For A to be conscious, the first action is the agent A should need some kind of perceptual states that the part of the external world. So the agent should be able to depict, to represent the external world. The second action says that the agent should be able to imagine. So not only the agent should be able to represent the external world, but the agent should also be able to imagine different world or recall parts of the experience, or fabricate new sensations. So imagine new sensations. The third axiom, according to Alexander, is the capability of attention. Many theories of unconsciousness focus on the problem of attention. So the agent is capable of selecting parts of the external world to depict or to image. So the agent generates some kind of image. Planning, the agent should be able to control the imagination state sequence. So the imagination must be used, must be employed in order to generate some possible states, in order to arrive to a. The fifth axiom, according to Alexander, is emotion. So the agent should be able to have some kind of affective states, able to evaluate the plans and to choose among different plans. So according to Alexander, the role of emotion in a conscious agent is to evaluate the possible plan in order to take action. Starting from these five axioms, Igor Alexander proposed a kind of architecture, which is he called the kernel architecture, made up by perception, memory, action, and emotion. So, according to Igor, this is the main idea of the main scaffold for every conscious agent. And this theory of Igor Alexander is well considered in the machine consciousness community, in some sense that every scholar that proposes a new architecture, in some sense, it compares. So, more or less, it is considered so that is every compare with it. Okay. In the current literature in machine consciousness, more or less, there are, in my opinion, there are three main models. Consciousness considered as information integration, and Fabio articulated. Consciousness considered as a kind of introspection and monitoring, and considered as a sort of internal. There are many other theories, but I would like to focus on this in this section. Obviously, it's like an elephant, so every model of consciousness takes only some part of the full problem of consciousness. So it is just like considering an elephant by the story of the scientists trying to understand what is an elephant only by touching some part of the elephant. So it's a snake, it's a tree, it's a fan, it's a square, and so on. So it's with consciousness more or less the same. Information integration. So according to theory, according with me, essentially consciousness, the main aspect of consciousness is that our conscious experience is integrated. So we do not perceive only by one of our senses, but we perceive with all our senses. We are able to integrate all the senses in a coherent perception. So, according with Tononi, let us consider this very simple experiment. Let's consider Galileo Galilei, as Tononi said, and a photodiode in front of a flashing screen. So imagine a person, a conscious person, and a photodiode in front of a flashing screen. And both the photodiode and the person should say when is on, in is on. Obviously, in simple the conscious person, Galileo Galilei, and the photodiode stays right at the same answer. So we don't need a conscious person to say if a screen is on or if a screen is off. But the problem is that the Galileo Galilei is able to discriminate among a huge number of states, while a photodiode is able to discriminate two states. So in order to consider information, we need to measure our information. So we need, for example, the entropy. Entropy is a typical way of measuring the quantity of information. But this is not enough. If we consider, for example, Galileo Galilei, which is able to discriminate among a huge number of states, a photodiode and a video camera in front of the TV screen, we could see the normal video camera, the modern video camera, are able to discriminate about an immense, a huge number of states. We have thousands, billion and billion of pixels. So both Galileo Galilei and the video camera are able to discriminate about a huge number of states. So the measure information is not enough to understand. We need some kind of integration. If we consider the video camera is made up by a huge number of photodiodes. So the information from the video camera is not integrated at all, while Galileo Galilei, or rather some conscious person, is able to integrate the information. So, according to Tononi, the main role, the main core of machine consciousness resides in the capability of the agent to integrate information. How do we measure the information integration? There is no time to enter the details, but let us consider this case. Let us consider a system S, which is subdivided into two parts, the A and B. And we perturb A by random, and we see what happened to B. If we perturb A, nothing happens to B. Obviously, this means that A and B are great, because A, nothing happens to B. And or if it is the case that when I perturb A, also B is perturbed, then This means that A and B are integrated. Continuing with this idea, Tononi measure the quantity of information integration by considering the BT system in order to reach the minimum integration. So he proposed that the phi of our system is able to integrate information. Phi is the measure of how this system is able to integrate information. This is because according to this, with high phi, with high measure, with high capability of integration, according to Tononi, the system will be able to have some. Okay. Starting from this idea of information integration, there is the theory proposed by Bernie Bars, global workspace theory. According to Bars, this kind of integration should be performed by a kind of global workspace. So, from the computer science term, if we have many compete to reach the control of the workspace, there are several processes that compete in order to reach the control of the workspace. The process that wins control the workspace and sending to broadcast messages to all the other processes and recruit the other processes. So according to Bars, this happens more or less into our brain. So there are many competing processes asking for the control of the global workspace. The process that wins then, in some sense, wins the competition. For example, if we consider if we have stimuli from vision, from audio, and so on, the stimulus that win the competition then is conscious. Okay, there are many implementations. Theory, for example, LIDA by Bernie Bars and Franklin. LIDA is a system able to implement this theory. Some years ago, Raul Arrabales, Spain, has been able to control a game by using a version of the LIDA system. Okay, the old views of consciousness is related with the introspection and monitor models of consciousness. Let us consider, for example, the good old VIRAP system in a paper published in 1998, in which VIRAP proposed a logical system with a meta system able to control the inferences in the low level. And also Drew McDermott, and the most famous approach, in this sense, is due to Marvin Minsky. Marvin Minsky proposes the emotion machine, written in a book some years ago, made up with several layers. The low layers are more related with instinctive reaction, learned reaction, and so on, while the highest level are more related with the self-reflective thinking, the self-conscious thinking. A similar system has been proposed by Aaron Sloman and Ron Priestley. It's an operating system, a working system you may download and try in your. The third one is the internal. This is, in some sense, called the matrix. So the hypothesis is that an intelligent system is able to build an internal model of itself, an internal model of the external world. So, internal model. Let us consider a system, an agent, interacting with the external world. A conscious agent is able to build a model of itself and a model of the external world. So, the interaction, so the system, the agent interacts with the external world, and in the brain of the agent, there is this interaction between the system and itself. So, in the extreme part of this theory, we are not conscious of our interaction with the external world, but we are conscious of the imagined interaction of our external world. Some of you may remember the movie Matrix, which is more or less the same thing. So we are not conscious of ourselves and the external world, but of the model of ourselves and the model of ourselves. This is the general framework of this hypothesis. We have a robot, we have a simulator, in which the robot simulates itself, and the robot compare what is the effective output, effective input from the video camera, and the imagined input from the simulation. So there is a sort of comparison between what is perceived from the robot and what is perceived from the simulated robot. Owen Holland, some years ago, proposed a robot which is called the Etch robot or Ecke robot, based on this. The robot has been able to build a model of itself and to interact according to the model of itself. Josh Bongard proposed another model, another similar model, the starfish model. It was a starfish robot able to build a model. It was interesting. It was able to build scratch the model of itself and of the external world. And also, we had some experiments years ago, teacher robot or kicker robot. It was a robot able to perform guided tours into a criminal. Also, in this case, in our experiments, the robot has been able to build a model of the museum, and so to generate expectation. The robot is starting from the. Okay, I'm going to finish my short lesson and I want to propose some kind of homework. In my opinion, the best introduction to consciousness is a scholarly book, but it is a novel book by David Love, which is English. The book is Things from Paris. But it's a novel, but it's a very rigorous novel. A very short introduction on the problem, on the general problem, including machine consciousness, is a short book by Susan Black. Consciousness, a very short introduction. There are many other books. Owen Holland, that I mentioned before, 2000 book of consciousness. Myself with Riccardo Manzotti published another book of machine consciousness. And now there is a book series of machine consciousness. I am the editor of this book series. We published so far 3 books, one from Igor Alexander, the other from Pentti Aikon, and the third one by Colin Howe. It is a book series related. There are also some websites that you may find slides, journals. There is the International Journal of Machine Consciousness. Today is discontinued. There are many papers in the website that you may find. There is the Journal of Conscious Studies. There is the Consciousness and Consciousness Journal. There is no specific conference on machine consciousness. Nevertheless, many conferences like the AGI, the conference, the General Conference, the ASSC conference, typically this. So if you are interested in machine consciousness, you may look for the program one. Essentially, the first 2, AGI and B, there are typically sections devoted to machine. While the ASSC conference is the conference of the scientific study on consciousness, and so there is more on the neuroscience side, but typically there are also papers related with consciousness. Okay, so very broad. What I discussed has been the axiom for machine robot consciousness. Three models of machine consciousness: the information integration model, the monitor model, and the internal model. There are other models, but in my opinion, three models in the current So, I would like to stop here for your
okay, thank you. So, any question? I have a question. How you relate the general research on consciousness to this paradigm of embodied AI? Which kind of links and differences do you see?
In my opinion, there are strong relationships. First, because so far we do not know any kind of conscious agent which is the animals are embodied, we are embodied, and in fact this is one of the problems of the paradigm. In some sense, this paradigm do not take into account the idea of embodiment. Nevertheless, the LiDAR, for example, the LiDAR model, the global workspace model by Bernie Farr, take into account the role of embodiment, see the process.
Okay, thanks.
Process is but nevertheless, this is an important point.
Okay, thanks. Are there other questions or comments? Okay, if not, so thank you for your lecture, your great lecture. Thank you very much.